Hello CSI 135 students. This is just a quick video tutorial to cover a number of the concepts that we've talked about in Chapter 6. The first concept that we want to take a look at is the fact that the Unix file system is hierarchical. And what that means is that it starts at a top level. And that level, as you see, is root. And root is designated by the /. So if I type in cd space / and type enter, and then type in pwd, you can see I'm now in the root directory. By typing ls, you can see that there are a number of files and directories in the root directory. And so again, if you think of it as an upside down tree, you start at the top root level and then you can work your way down into what they would call children directories or subdirectories. And so if I type ls minus capital F, the capital F will place a / after any directories. And as you can see, we have a ton of directories in here, right? So if you were making your directory tree, it would start with root, and then under root you'd have apps, boot, etc, lib, media, mount, opt, root, which is ROOT spelled out, SE Linux, sys, U, var. So let's take a look down, let's look at U. So I'll go to cd u, right? Now the reason I can type in cd space u, which is the relative path name, is that I am in the directory, I am in root, right, where u resides. So I could type cd/u, but since I'm already here, I'll type cd space u. Now once I'm in u, I'll type ls, and if I do an ls dash capital F, because I'm interested in what directories are in here, you can see again, here are more subdirectories underneath /u, right? So / was one directory, we came down to u, and now we've come down to see these directories here. So I could come down to students, and again I could type in cd space /u /students, but since I'm here in the same directory where the students directory resides, I can use the relative path name. So cd space students and then hit enter. So pwd, I'm now in /u /students. So if I type ls, you can see that there's another series of directories. If I use the capital F, it'll place the / at the end of anything that's a directory. So let's take a look and see what happened in the fall of '09. Well, permissions denied, which means as a student, I don't have permissions to go in there. Let's see if I can get into spring of 10. No permissions, right? So let's take a look. ls minus L will show me the permissions. So as you can see, and we talked about permissions this evening, the owner and the group, so if you're not root and you're not in the root group, the last 3 bits of the permission set, right, these last 3 dashes here, or the X-R here, will dictate whether or not you can cd into the directory. So it looks like summer 12 for anybody else, right? Remember, it's the first 3 are owner after the file indicator is a directory file or regular file or special file. So the first 3 are for the owner, the next 3, read, write, execute, are for the group if you're in that group, and the last 3 are for everybody else. So according to this, read, write, execute, I should be able to get into summer 12. So let's see what was going on in summer 12. And sure enough, no error message saying permission denied, so this worked out well. I type ls, and it looks like it was just CSI 135, right? And we had an A section, a B section, C, and D. So if I type ls with the capital F, you can see that these are all directories. And so again, very similar to this semester where you are CSI 135 and then your home directory is B, and if you're B11 it's B11, B25 is B25. So let's take a look at the directory permissions here with the -L, and you can see that all the student directories are 700, right? So read, write, execute 7, and then if it's all dashed out, that means they're not on, right? Those bits are not flipped on. So they're off. So it's 700. So unfortunately, right, it's owned by student, and it's owned by student, and it doesn't look like the group is in existence anymore. All right, so if I were to try to get into one of these directories, I could type in cd d9, which is the one right there, and you can see we get permission denied, right, as we would expect. Again, keep in mind that in order to cd into a directory, you need to have execute permissions, and let's check that out. So if I were to cd into the temp directory and make dir, and we'll call it, gotta get creative here, Apple, right? So if I do an ls-l on Apple, I can see that the directory is empty, right, because I've just created it. If I cd into Apple and then type ls-l, still nothing here, right? So let's go back up one directory, type ls-l and temp. I'll have to scroll back a little bit, and we've got quite a bit going on here. So you can see Apple is 755. So it's read, write, execute, read and execute for the group, right? So the first one is the owner, so I have full permissions. The next set of bits is for the group. So the group can read what's in here, which means they could list the contents out. They can execute on the directory, which means they can cd into it. And they can also read, and then everyone else, if you're not me, right, because I'm the owner, and you're not in the student group, then you can do read and execute, which means you could list out the contents or cd into the directory. So let's make a change on that. So if I typed in chmod 600 on Apple, right? So now if I try to cd into Apple, you can see even though I'm the owner, because the permissions are 600, I get permission denied. To fix that, again, so I'm the owner, I can make the change. I could type in 700. Ooh, whoops, sorry. Chmod 700 on Apple. And as you can see, now when I try to cd in, I can cd in there. And that is now my current working directory. So again, that's what the execute command on a directory allows you to do. Okay? All right, we also talked about file names, and here are some interesting file names here. Right, I have hello.c, so if I cat that, you can see the hello.c is basically it's the ubiquitous to see or not to see, that is the question, which usually they give you at the day one if you're taking C programming. So file names, right? I can use the touch command to create files, and you can create, oops, no, with the semicolon in there, you can create files that have very long names, right? And you could also create files that have special characters. And again, the touch command is simply creating an empty file. So I can use uppercase, I can use lowercase, I can use numbers, right? I can use underscores, and you guys have seen this before because I've created a number of directories. I can use periods, right? And I can use commas. So that's a pretty odd file name, but there it is. I could also create a file that just has periods, right? Now, what if I tried to create a file with just a single dot? Does it work? Oops, sorry, ls minus la, right? Does it work? So the dot is already there because that's my current working directory. So what if I try to create dot dot? Yeah, I get permission denied because, oops, dot dot is owned by root, and root is the group, and I'm not, since I'm a student here, right, I'm just CSI 135B25. You can see the group has read and execute, but I do not have write, which is what I would need to modify that entry, right? So if I type date, you can see the current system date and time at this point is 7:48. So let's see, if I touch the dot, does that change the date on it? Does it change it to 7:48? And it does. So you can see by touching a file, it updates the timestamp on that file as to when that file was changed. And so if you come into the man page on touch, you can see that it gives you a number of options that you can use with the file. And you can see what the version is by using -- version, right? And it updates the access and modification times of each file to the current time. And what that should say is to the current system date and time. So again, let's take a look at some of the other files in here. And let's look at something a little older, right? How about my stuff, right? So you see my stuff is February 10th at 10:24. So if I type in touch my stuff and then we do LA, let's come take a look at my stuff. All right, it is 7:49 in the morning. Oh, and it just rolled over to 7:50, but the current system date and time when I ran the command was 7:49. So touch can change the time. Another interesting fact are file name extensions, right? And in fact, let me remove these guys. All right, so we'll remove those two files, make it a little easier to read here. So file name extensions. So typically, file names that end in .c represent C source code files. Files that you have compressed, right? So if I want to compress, I'll do bzip2 minus v because I want to see the output on my stuff, right? And now the file ends in bz2. So we know that this file is a compressed file. So, and how do we check? I can use the file command, right? There we go. mystuff.bz2, it's a bzip2 compressed file, right? Block size 900K. So what if I type file on junk, which is just simply an ASCII English text file, right? What if I type file on a.out? That's correct. It's an executable because I compiled the C source code here and it created this program. So if I were to run that program and I can just type a.out, you can see that to see or not to see, that is the question. And that was the information that was in the hello.c file. Now remember that file names that begin with a period are considered hidden files. So how many hidden files are in my home directory here? As you can see, I've got a number: .bash history, .bash logout, .bash profile. So anything that begins with a period, .exrc. And those are files that when I simply type ls are not displayed. You need to make sure you use the -a, right? If you want to see the permissions for everything, you can combine al. Let me check to see what the inode, and we'll talk about that. We talked about that this evening as well, right? Where or what is the inode number? And you use the -i, right? And so I'm combining. I want to see hidden files. I want to see all the permissions, and most importantly, this first column, that is your inode number. And remember, it's on a file system that the file will have a unique inode. So on each partition, and you view the partitions by typing df space -k, you can see that for //user /var/apps, these are partitions. So files on these partitions will have unique inodes, and that's also the reason that a hard link cannot span different file partitions, because you can't guarantee that the inode is going to be unique across those different partitions. All right, so let me go back into the temp directory. So how do we remove directories? Again, rmdir, and I'll get rid of Apple, will remove the Apple directory, right? Now, let's say there was something, I'll do makedir Apple. And let's say if I was in Apple and I had created a file, let me copy etc hosts to this directory here to Apple. So now when I go back up, I type rmdir space Apple. It's going to tell me the directory is not empty. So if I know, if I'm 100% certain that I don't want anything inside that directory Apple, and including subdirectories and other files that may be in those subdirectories, I can type in rm minus rf and then the name of the directory, right? And that'll remove it. So now if I try to cd to Apple, I can't. I just removed it. It's gone, right? Okay. We also talked about file access permissions, right? And again, to display those, it's ls-l. And remember, the very first bit, right, that's shown here, this is the file type. D for directory. If it's a dash, it means it's a simple text file, right? Or it's not a directory. Because as you can see here, this tar file, right? The dash means that it's not a directory. So if I am in the temp directory and I were to ask you what in numeric value are the permissions for the file yo, which is empty, it's the owner, who is SHS, has read write turned on, and then read for the faculty group, and then nothing else for other, right? So that would be 640, because again, the R has a value of 4, the W a value of 2, and the X, which is not on here, is a value of 1. So the maximum that it will ever be will be 7. So if you can count to 7, you have a very good chance of getting the permissions right. Okay, so in addition to talking about permissions, we talked about changing permissions, right? So if I have a file here called, we'll create a file called Apple. So if I type ls-l on Apple, you can see the default permission set, which is the set of permissions that's given at the very beginning, right when you create it, is 644, right? 644. So let's say I want everybody to be able to read, write, and execute this file. I could type in chmod 777 Apple. So now when I type in ls-l, you can see read, write, execute, read, write, execute, read, write, execute. But let's say I only want myself and anybody in the student group to be able to go in and look at, or to go in and do everything on that file. I would type in chmod 770 Apple. If I type ls-l to see the let me clear that out. ls-l on Apple, you can see 770. What if I wanted it to be that I had full permissions, that people in the student group could only execute the file, and that everybody else could only read the file? 714, right? Now ls-l on Apple, and that shows you that I have 7, right? 4 plus 2 plus 1, read, write, execute, so that's 7, and then dash dash execute, right? 4 is not on, 2 is not on, 1 is on, so that's my 1 here in the permissions, 7.1, and then read dash dash, so 4, right? All right, so that's a good explanation. Now it's interesting when they show the letters. Let's say that you wanted to give the owner of the file execute permission. So let me chmod to 000 on Apple, and then let's see what that looks like. Well, sorry about that. ls-l Apple. So here we go. Look at that. 000. Nothing. I can't do anything to it. So let me change the permissions. So I'll do chmod, and let's say all I want to do is give myself execute. I would do u plus x, right? Oops, sorry. Chmod u plus x on Apple. And if I type ls-l Apple, you can see I just gave myself execute, right? What if I wanted to give the group student, I'm going to give students full permission. So I could do chmod space g plus, and we'll do, let's see, what would be a good match here. So let's see, we'll give the students permission to do read, write, and execute. How about that? So we'll do read, write, execute on Apple and hit enter. Now when I type ls-l on Apple, so I don't display everything in the temp directory, you can see that this is still here, but now read, write, and execute has been added. Remember up here it was just I added u plus x, which means the user, the owner, gets execute. Here I've added the group gets read, write, and execute. But let's say, hey, you know what? That's really not what I intended. What I'd like to do is for the group, I just want them to have read and execute, no write. So I'm going to type in g minus w. So for the group, I'm going to take away write permissions on Apple. And now let's take a look and see what that looks like. ls-l on, whoops, be careful I don't hit enter after the L. All right, so there we have it. That's how you would remove the permissions with the minus sign, right? Okay, so that's a good look at the file permissions. And last but not least, we're going to take a look at links, right? And links are very interesting. So there's two types of links. There's hard links and then there's soft links. So the first link that we're going to look at is going to be the hard link. So if I have that file still, Apple, right? And there it is. And I want to create a link to that file. And basically what I'm doing is, this is going to be a pointer, but it's actually going to share the same inode as the file Apple. So I'll make this easy in fact, let me go to my home directory here. So if I create a file called Apple and I want to link to that file, I could type in ln space the name of the file to which I am linking, right? So that's Apple, and then the name of my link. And I'll call this Apple underscore link, right? So it's successful, no error message. So if I type ls-i in my home directory, it shows me the inode number before the file name. So the inode number for Apple is 117.9918. Where is Apple link? Right here, 117.9918. So if you were to be asked, identify the link, the two files that are linked together in this directory, you would simply type ls-i, and then you would see the inode numbers, and the inode numbers that match indicate that those files are linked. Another way to do it would be to do ls-l, but this is a little tricky because it's in this column here. This is the link count, right? So directories will always have two or more links, right? And you can see here, these guys each have two links. So there's a very good chance that they're linked together. So that's another way you could narrow it down. Just remembering that because the directory has two does not mean the directory is linked to these files, right? But if you had two regular files that each had two, there's a possibility they could be linked. You do ls-i, and then you could determine that. All right. Now, hard links cannot span partitions, right? So when I did df-k, you can see here that /root and the U students are different partitions. So if I tried to link my file Apple into the temp directory, and I'll call the link Apple underscore link, I'm going to get an interesting error message here. It's going to say, creating hard link, temp Apple link to Apple, invalid cross-device link. And what that means is you can't cross partitions, right? So how do you overcome that limitation? You can simply do that by using a symbolic or soft link, right? So ln-s, right, and the -s stands for symbolic. I can type in Apple and then /temp/Apple underscore link. Now here's what's interesting. A symbolic link simply points to the path name of another file. So if I type ls-l here, right, you can see we have Apple. But if I go into temp and type ls-l, I'm going to have to scroll back up. Let's take a look. So here's Apple underscore link. And what is Apple underscore link? So again, that first bit, L, stands for link. The permissions are 777, right? So everybody has read, write, and execute on this link. All right? And it's simply a pointer, right? You can see the little arrow. It just basically says, hey, Apple underscore link points to Apple. But does it really? So if I cat Apple, I get permission denied, right? So it's not really there, and the permission set is not allowing me to view it. I'm sorry, Apple underscore link, Apple underscore link, and it comes back, says the same thing, permission denied, right? Because the file Apple doesn't actually exist in this directory. So if I create a file here and call it Apple, oh, whoops. Let's see. Yes. I need to remove Apple. All right. So now if I were to cat Apple underscore link, it says no such file or directory. That's what I was expecting. So it says no such file or directory. Now the reason it says that is because the file Apple, right, ls-l Apple, that file doesn't exist here. And if you look at this link, is it pointing to the absolute path name or the relative path name? It's clearly pointing to the relative path name, right? So if I were to copy Etsy hosts into Apple, right? Now if I do a more on Apple, I've got the Etsy hosts file here. So now if I cat apple underscore link, you can see that now there is a file. But when I remove the file that the link is pointing to, and I run that command now, it simply tells me no such file or directory. And again, symbolic links do not share inodes. All right, hope you guys found this tutorial helpful, and please be sure to contact me if you have any questions. All right, have a great night.